Hello, my name is Jorge, and I'm going to present to you our course project that is our final assignment in Machine Learning Foundations for Product Managers. So let's start. First, let's start with business understanding. I'll try to implement here the CRISP-DM process. So that's our first stage. Our objective is to build a model to predict the electrical energy output of a combined cycle power plant, which is a CCPP, using ambient environmental readings from sensors at the power plant. Considering this, a data set was given with more than 9,000 hourly average ambient environmental ratings. So those are observations. In it, we can identify some columns that are temperature, ambient pressure, relative humidity, exhaust vacuum, and our target value that is net hourly electrical energy output. And of course, the rest would be possible features for us in the problem. What would define success is to implement a model that can predict the electrical energy output, minimizing as much as we can the error to ensure accuracy of it. And possible outcomes, I came up with two that would be to actually optimize or even just predict the revenue for the CCPP. Now, deep diving a little bit into our problem and the data, considering that we have at least some past observations of features and targets, and that we have a target value for our observations and multiple features, it's really easy for us to set our scenario that is actually a supervised learning problem, and we can even narrow already that it's a multiple linear regression because we are targeting a value having multiple features. So that's what we're gonna aim when training and actually selecting models. And after putting all the data that we have in Google, it's really easy for us to get a correlation between features and the target. So V and AT seem to be way more correlated to our target, so we're going to use that as well during our training of the model. And jumping into data preparation, using Google Vertex AI, we separated our data between training, validation, and tests. So it's 80%, 10%, and 10% to prevent data leakage. And already jump into modeling, again using Google Vertex, we already selected a regression model for optimizing MAE, as we don't really want to penalize outliers that much considering the context of our problem. Alright, now after actually training the model, we came up with the results already here, but what I did was actually creating some versions where we would iterate between having all the features or actually having less than that, because we saw that the correlation was really different for some of them. Then our version 1 is a version where all the features are implemented and the model is optimized for MAE. Version 2, all the features apart from RH are optimized for MAE. And version 3 is where all features are implemented apart from RH and AP, and it's optimized for MAE as well. Here it's really clear that our first version is the best, but it was a good exercise for us to see what happens when we iterate the configuration of our model to actually try to optimize it more. So with this, we come to the conclusion where after multiple iterations, it was clear that our model with all the 4 features should be the one selected for our scenario, as we achieved the lowest AMAE with this version, which is 2.46, and we achieved the highest R squared as well in this, that was 96%. So that was it. Thank you for the course. It was really useful, and I hope I can use that on my day-to-day work. Thank you.